In today's video, we'll look at section 7.3, use similar right triangles. So before we looked at the altitudes of triangles, now we're going to use the properties of the altitudes of a right triangle. This is going to help us solve some problems in finding more unknown lengths. So the first theorem we want to look at is just theorem 7.5. If an altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle and to each other. So if we see that we have our main triangle ABC in black here, we can take out ACD, create another right triangle, and then we have CDB as another right triangle. And these are all similar. Remember, all the angles are the same and all the sides are proportional. So that's what we're going to look at. That's how the altitude can help us with finding unknown lengths. And we're going to show that here in a little bit. So the first thing we want to look at. Here are just some examples of how they line up. All the sides are matched up with lengths, okay? And how they set together. So we can see here we have ABC, the big triangle. So we have D as the hypotenuse here. And then its hypotenuse, okay, is split up. AD is right here, and it's only a part of the hypotenuse, and BD, now another leg, is a part of the other part of the hypotenuse. CB is a leg on the big triangle, but it is the hypotenuse on the smallest triangle. AC is another leg on the big triangle, but it is the hypotenuse on the medium triangle. And then the altitude of the big triangle becomes one leg of the medium triangle and one leg of the small triangle. So let's identify the similar triangles. So first, we have the big triangle. So I'm going to highlight that in red. Okay, so we have RST. So we have triangle RST. So the way I'm writing this is that I'm putting the right angle last so to help us identify. So let's move this here a little bit. Okay, and now let's do the medium triangle in green. So now I have triangle, now we got to match up. So angle R matches up with angle R, and then the right angle would be U, so it's going to be RTU, because I got to have the right angles match up. And then the last one, the little triangle, we can see how it's split up. It's going to be triangle T, and then the right angle is U again, so TSU. So notice how I split all of them up to be able to create similar triangles. And that's what we want to start really being able to identify. And since they're similar, that means we can create some proportions with it. And these are some of the proportions. So the geometric mean, the mean we learned in the previous lesson, is called the altitude. So the geometric mean theorem, in a right triangle, the altitude from the right angle to the hypotenuse divides the hypotenuse into two segments. The length of the altitude is the geometric mean of the lengths of the two segments. So essentially what they're saying, if you pay close attention to the proportion here, we have BD over CD is equal to CD over AD. So it creates a little perpendicular symbol. So now if we do this in different colors, so we can see here, it follows a little bit of a line. So we have BD is equal to, BD over CD is equal to CD back down over AD. So it creates a little, you just kind of trail your steps. The other one, the geometric leg theorem. Now this one has two of them. In a right triangle, the altitude from the right angle to the hypotenuse divides the hypotenuse into two segments. The length of each leg of the right triangle is the geometric mean of the lengths of the hypotenuse and the segment of the hypotenuse that is adjacent to the leg. So yes, that is kind of wordy, but again, follow the steps. So AB over over CB is equal to, and then I'm going to trail back, is equal to CB over DB. Okay, and then if we follow the exact same thing here, AB over AC is equal to AC over, and let's pick a color here that we can use, can you ignore, AD. So we can follow these steps here. If you just follow the path here, it's kind of nice. So everything's always touching. So notice, and if you look at like the second one, AB over AC equals AC over AD, CB was not ever touched. The segment CB was not ever mentioned, and neither was CD. So we can always follow these steps. So essentially, hypotenuse over leg equals hypotenuse over leg. That's how you can always think of it. So find the value of y. So we got a couple we got here. So we have the way it's set up. We can look at this. We can go hypotenuse, so 9, over its leg, RQ, y, is equal to, going back up the leg, y over the short part, 3. And there is our setup. There's our proportions. So now, simple game of proportions. Cross multiply. So we get y squared is equal to 27. Take the square root on both sides. So you get y is equal to 5.2, or approximately actually. And there we go. There's the value of y. Next one, find the value of x. So here we got a little bit of an issue here. So we got to do a little bit of finagling. We have to find the pieces. We have to find EH in the first one. So I'm going to call this y just so we have something to work with. So we can say 5 over 3 is equal to, and then I'm going to go back up, 3 over y. And there we go. So now I can simply solve for y, cross multiply. So we get 5y is equal to 9. So I get, let's just show our work here. Divide both sides by 5. So I get y is equal to 1.8. And now I have y, so that means I have 1.8 here, and then this side is 3.2. So now I can use either the geometric mean or I can use the Pythagorean theorem. Either one would work here and we'll get the same answer. I'm going to use the Pythagorean theorem, but then I'm going to show you that the geometric mean one would also work. Okay, so I'm going to do parts here. So 1.8 over x is equal to x over 3.2 for the geometric mean. So 1.8 over x is equal to x over 3.2. So x squared is equal to, I'm going to grab my calculator here, 1.8 times 3.2 would give us 5.76. And then we take the square root on both sides. So we get x is equal to 2.4. Okay, so that's using the geometric mean. Now let's use the Pythagorean theorem. And I'm going to use the Pythagorean theorem with the purple triangle here. So we have 4 squared is equal to 3.2 squared minus plus x squared. So I have 16 equals 10.24 plus x squared. Subtract 10.24 from both sides. And I get 5.76 is equal to x squared. And look what we got, the same exact setup. So one can be faster than the other, but they both work. So I'm typically going to stick with whatever one's quicker. And it looks like in this case the geometric mean was quicker.